Hi guys, it's Mrs. Cerami with 9.3. Just so you know, because it's online, I'm going to keep it really simple. And if you look at the book, the conditional or the binomial, we're going to cut that out for now. We're going to start with the quote. The Lord is good, a refuge in times of trouble. He cares for those who trust in him. So keep praying, keep trusting. All right, so 9.3. First thing we're going to talk about is sample space. Sample space is an integer number. It's a set of all possible outcomes. So how many times, like what can happen? So this slide here, we're going to talk about possible outcomes. What is the sample space when a dice is rolled? So when a dice is rolled, how many options do we have here? So we know that when a dice is rolled, or one die rather, you can roll 1, a 2, a 3, a 4, a 5, or a 6. So the sample space would be 6 possibilities. So it's out of 6. What is the sample space of the number of outfits you have if you have 4 pairs of pants, 2 tops, and 3 pairs of shoes? So we know that we're talking about pants, we're talking about tops, and shoes. And if you recall from previous section, if you're comparing different items, you use the counting principle. So we have 4, 2, and 3. So we multiply that together and we have 24 different possibilities. So the sample space is 24. What is the sample space of a deck of cards? Well, there's 52 cards in a deck. So that would be the answer for that. Okay. Now, probability. You use sample space within probability. That is going to be your denominator, and your numerator is going to be what you're choosing out of. So tossing a head on one toss of a fair coin. So if you're tossing a coin, the sample space is 2. And what we want, what we're looking at, okay, we'll put eyeballs here with eyebrows. What we're looking at is we want to toss a head, so it's 1 out of 2. Rolling 3 and a die. Again, the sample space is 6. We want to know what we'll have for a 3, so it's 1 out of 6. Drawing a queen from a standard deck of 52 cards. Well, there's 52 cards in a deck, and there are 4 queens. And you always have to reduce 1 out of 13. Now, probability, just so you know, it could equal a fraction, it could equal a percent, and it can also equal a decimal. Not picking a heart from a standard deck of 52 cards. Not picking a heart. So instead of figuring out all the other cards that are not a heart, I'd figure out what's the probability of picking a heart. Well, there are 4 hearts in the deck. So that means that not heart would be 52 minus 4, which is 48. So that means we'd have 42 out of 52 that are not a heart, and you have to reduce. So you can divide by 4, and you get 12/13. Picking an equation from a standard deck of cards. So again, picking an equation from a standard deck of cards. So how many equations are there in a deck of cards? Well, none. There's nothing in there, 0. So if something does not exist, it's 0. So if it does not exist. So when I said integer, it's really whole number. For probability, it goes from 0, and then the highest you can go, we'll see in the next one, picking a black or red card from a standard deck of cards. So all cards are either black or red, so therefore it's going to be all the cards, 52 out of 52, which is 1. So this is the highest you can go, and this means that it must happen no matter what. It must happen. So the probability of an event happening is going to be greater than or equal to 0 or less than or equal to 1. If it's 0, it's impossible. And if it's 1, it must happen. Or it must occur. The sum of all probabilities of all outcomes is 1, because that means it all will happen. And sometimes you'll hear empty set. Probability of empty set is 0, impossible to happen, just as a summary. So find the probability you'll pick one card that is a king or a heart. Well, we have 4 kings and we have 13 hearts, but we have one card that's a king and a heart together. So it kind of doubles in both. We have the king of hearts. So you're going to deduct one from either the king or the heart. So if you start with 4 kings, you're going to have one less heart. So that means the probability is going to be 16 out of the total 52, because it could be one or the other. Both are acceptable. So you have a total of 16, and then reduce, divide by 4, and you'll have 4 over 13. If you didn't see divide by 4, divide by 2, and 2 again, or you can use your calculator, put that in, and then use the fraction key. Find the probability that you choose a heart or a picture card. So we have 13 hearts, or I can have a picture card. So picture card is Jack, Queen, and King, and there's 4 of each. 4 jacks, 4 queens, and 4 kings. But each of these have a heart already. So we've already included these cards with all the hearts. So altogether, we can have our 13 hearts plus 3 of the other of jacks, and 3 of the other of queens, and 3 of the other suits of kings. And it's all over 52. So we're going to have 13, 16, 19, 22 over 52, which is 11 over 26. Find the probability you'll pick one card that's a king and a heart. So they have to both have that in common. So how many cards are a king and a heart together? Well, we know we have 4 kings, and it's either going to be a heart, a club, a spade, or a diamond. So we only have one card of the whole deck that's a king and a heart. 1 out of 52. Find the probability you choose a heart and a picture card. So again, we have for picture cards Jack, we have Queen, and we have King. And we want to make sure that they're also a heart. So we have 1 heart that's a Jack, 1 heart that's a Queen, and 1 heart that's a King. So altogether, it's 3 out of 52. And you can't reduce that. Now, this one's a little bit different of a setup. The maker of a candy that comes in the colors on the right gives a proportion. So this is the proportion of each color of candy. A single candy is drawn at random. Find the probability that a candy has the following colors. So it's asking for, find the probability that a candy is neither pink nor green. So a lot of times when you have neither, you want to figure out what the probability of this is and then just subtract it from 1. So you want us to do 1 minus the probability that it's pink or green. So what's the probability that it's pink or green? Well, pink is going to be 0.1 and green is 0.3. And when it's OR, we want them together. So 0.4. So the answer would be 0.6. Now, just to point something else out, it says this is the proportion. If you add all of this together, you're going to get 1.0. Okay, that's the total. So when it says proportion, this would be 20% blue, or 2 out of 10 blue, 1 out of 10 red. It kind of gives you the information for you. All right, so now you're just going to do about 5 problems on my math lab, very short problems. Just to reinforce Algebra 2, you will see something like this on the SAT, so it's important to cover it. Hope you guys are having a great day and reach out with any questions. Bye.